We're going to start taking a look at numerical ways to start describing data. And we're still talking about descriptive statistics rather than the inferential types. In fact, we're going to be talking about descriptive for a little while in the course. So we're going to start by talking about this idea of central tendency. Central tendency is indeed a measure of where the majority of the data lies. And for most of us, we probably remember the 3 M's as the measures of central tendency. So we have the mean, which is the numerical or arithmetic average. There are different types of averages, believe it or not, weighted, geometric, etc. There's the median, which is the middle number or numbers in a set of data that's listed in ascending or lowest to highest order. If for some reason the number of observations is even, then you just take the average of the middle 2 terms in the list. And then finally, the last M is the mode. That's the most frequently occurring. It is possible to have more than one mode. It is possible to have no mode in the list. And we'll see some examples of this later. Now, if for some reason we have some outliers present, that affects the median specifically a lot. The median tends to be sensitive to outliers. So if there are no outliers present, in general, the mean is the best measure of central tendency. I'm sorry, if there are outliers present, the median is the best measure. However, if there are no outliers, then the mean is a better measure. And one thing that we tend to say is that the mean is sensitive to outliers. And I'll give you an example of what that means in a moment. The median is resistant to outliers. So, and just as a really basic example, let's say I have the list 1, 2, 3, 4, 500. All right, maybe somebody made a non-sampling error and they put 500 in here. Now, clearly, the median of this list would be 3, okay, because that's the middle number. All right, all we have to do is just see that that's the middle number. The mean of this list would be 1 plus 2 plus 3 plus 4 plus 500 divided by 5. And that would be equal to 102, since I believe that's going to be 510 divided by 5, which should be 102. Now, it's almost certain that everybody can see that 3 is a better descriptor of the majority of the data. 1, 2, 3, 4. Most of the data is between 1 and 4, so 3 is a pretty good center of that data. However, the mean must include that 500. The median tends to exclude any outlying data, right? So hopefully that makes sense as to what we mean by resistant and sensitive to outliers with respect to median and mean. All right, so that being said, we have 2 different types of means. The population mean is given by this variable mu. All right, so whenever you see this variable, it looks like a U with a tail on it. Okay, that's pronounced mu, and that means we're dealing with a population. All right, so that way everybody knows that we have every single observation. And remember, when we're dealing with population summary values, that's a parameter. This variable we're going to pronounce x bar, and it's pretty obvious as to why we call it x bar, and that represents that we have a sample statistic. All right, or in other words, we just have to go through and recognize that we're dealing with not every observation in the population. Almost always, we're going to be computing x bar. All right, mu a lot of times is given to us. It's not always known. All right, though there might be times to where we can find mu. All right, so just kind of getting those under our belts before we go through and start talking about computations. All right, so that being said, let's go through and let's find the sample mean, sample median, and the mode of the following sample data. All right, so we have these observations. One of the first things that we might wish to do is we might wish to get the sample size, because we can't find the sample mean unless we have the sample size. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. And then the other thing that we have to do is we have to add up these values. All right. So Now, what we're going to do is we're just going to go to our calculator, all right? And notice what I did beforehand was I already just added them up, all right? And essentially what I did was I took 0 plus 39 plus 41 plus, and then I just kept entering, all right? I'm not going to do that again. But the sum of all those numbers is 618, all right? So going back to our screen and our formula, what we're looking at right here, right? So whenever we see this symbol, right, that just means the sum of. And the x sub I represents observations. Right? So basically, whenever you see sum of x sub I, that just means the sum of the observations. All right? It's just a fancy way of saying that. Right. So essentially, to find x bar, that's going to be equal to 618 divided by 14. All right? We can go back to our calculator, type that in, and we end up with 44.143 if we were to round it off. And of course, we want to make sure that that number makes sense. And obviously, because 44 is at least somewhere in the middle of the data, then that does make sense. All right. Now, what about the median? Well, an easy way to find the median is just to start crossing off numbers as long as they're listed in ascending order. All right. So I'm going to cross off from the ends. I'm just going to keep crossing off until I get to a middle number or numbers. All right, now, notice what happens is that we're left with 48 and 49. All right, there's two middle numbers. So the median is going to be defined as 48 plus 49 divided by 2. Or in other words, that's going to end up being 97 over 2. And if we want to use our calculators, we certainly can. That'll be 48.5. Right. Now, notice these numbers are slightly different, all right? And we'll explain why in a moment at the end. Right? Last thing we're going to do, we're going to find the mode. I want you to notice that 41 occurs 3 times, as does 40 or 53, excuse me. So there's actually 2 modes of this list. So the modes in this case are going to be 41 and 53. And if you're a statistician, the question is, which is the best measure? Well, I think everybody can agree that 0 is an outlier, just by inspection, all right? There's not really any sort of scientific proof of that yet. We will later in the course when we start understanding deviation a little bit more. So because there's an outlier, what we can say is that the median is the best measure. Okay, so if I were to try to best describe the center of data, probably 48.5 would be the best measure, right? That's why you hear things like medium income, because there are people that make a lot of money, but that isn't reflexive of the general population. Okay? So hopefully that makes sense as to how to find central tendency for sets of data. Another measure of being able to work with center of data is the idea of a 5-number summary. All right, so a 5-number summary is comprised of 5 numbers, and it basically tries to give us a good snapshot of what the data might look like. And so we have a Q1, a Q2, a Q3. Those are called the quartiles, and then we have a high and a low. Okay, so Q1 is the first quartile. And then Q2 is the second. Q2 is also the median. All right, so, and then finally Q3 is the third quartile. And essentially what these do, they designate the 25th percentile, the 50th percentile, and the 75th percentile. All right, so it's a good benchmark as you go through to be able to try to figure out, you know, in relation to your data, what numbers make up like that 50th percentile or what's above the 75th percentile, etc. All right, so let's take a look at a couple examples of just finding a 5-number summary. So we have female and male shoe sizes, right? and they're randomly selected. And what we're asked to do is we're asked to find a 5-number summary for both of these, all right? So really easy is the low and the high. And I'm just looking at the male data. The low for the male data is 8. The high for the male data is 15. Nice and easy. Q2 is going to be the next thing that we find. All right, so whenever you're finding a 5-number summary, you want to find low and high first. They're easy. Q2 is the median. So all I'm going to do is I'm just going to cross off numbers at the end. And I'm just going to keep going. And notice what happens is that we end up with 2 middle numbers. We end up with a 10 and a 10.5. And you might recall that if we have 2 numbers in the middle, we just add them and divide by 2. So 10 plus 10.5 divided by 2, that's going to be 20.5 divided by 2, which is 10.25. The next thing we're going to do is we're going to find Q1. Now Q1, by definition, is the median of the lower half of data. All right, so for us, what we're going to do is we're going to split the list exactly in half. All right, and the list is divided right at the median. So notice right here, we have a split in the data. Right? And all we're going to do is just find the median of the lower half and then find the median of the upper half. And median of the lower half is going to be Q1, median of the lower half is going to be Q3. So we do it again. We're going to cross off the ends. And eventually what we end up with is just 9. All right. So hopefully that makes sense. Notice that there's 7 observations. All right. So 1, 2, 3, 4, 5, 6, 7. And so we basically say in the middle of 7 is going to be 3. All right. So there's 1, 2, 3, and then there's 5, 6, 7. So in the middle of that would be 4, excuse me. So the 4th observation. Same thing with Q3. So we're just going to cross off the ends once again. And eventually we end up at 11. So Q3 is going to be 11. All right, finally, we can go through and do the exact same thing for the female data. All right, so we're going to have a low, and we're going to have a high, and then we're going to have Q2. So the low is 6, the high is 11. Let's go through just like we did before, try to find the median. So we have 11, 6 cross out, 6, 10, 9.5, 7, 7, 9, 7.5, 9, 9, 8, 8, 8.5, and then we end up with 8.5 as the middle number. Notice this time there's only one middle number, so that's what we pick. Right? Just to make sure, we can always count. Right? So here's a way to check this, just to make sure you're right. Okay, so we said that 8.5 was the median. And notice that there are 1, 2, 3, 4, 5, 6, 7 numbers to the left. And there are 1, 2, 3, 4, 5, 6, 7 numbers to the right of the median. If those numbers are identical, you've done it right. If they're not identical, you've done it wrong. Just to illustrate, let me go back up here. And we could do the exact same thing. The number, there should be the same number of observations to the left of that yellow line, or I'm sorry, that orange line, and then to the right. So counting 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. It's not always going to be 7. It's just in this example, it's just what it happens to be. All right, so just reinforcing that that's how we make sure we've done the median correctly. Now we still haven't found Q1 and Q3, but that'll be easy at this point. All right. So for Q1, we're going to cross the ends out again. And eventually we just end up with 7. And then we go over here and do it. And we end up with this 9. All right, so hopefully that makes sense as to how to go through and find the 5-number summary. In the next video, what we're going to do is we're going to start to be able to graph this, and then we're going to take a look at a numerical measure of how spread out the data is, which is going to be called our standard deviation.